And then you can have linked regressions or hierarchical models. This is one that we developed for sorghum ergot, where we have a relationship with pre-flowering cold stress. Pre-flowering cold stress affects meiosis and the viability of spores that are produced. And essentially, to escape ergot, you need a large volume of viable spores. So you have cold stress that affects, not spores, sorry, pollen. Try again. Okay, so here you have a relationship for pollen production. Here you have minimum temperature during the early flowering period, the relationship with daily maximum relative humidity, and you add all these models together and you link these regressions, and you can get a fairly good prediction of how much ergot you're going to get. So in other words, now you're getting into disease prediction models and various other things. I'm not going to go into area under disease progress curve. That was covered yesterday, the day before. But very often we used area under disease progress curve as an integrated or a synopsis of the disease over time. And we can use that in yield loss models. Again, you know, and what this actually is a multiple model, because you're taking your disease progress curve, you've got multiple measurements. You're combining them into a single index of disease, and then using that to measure yield loss. So in other words, it's a multiple model that you've simplified into a simple regression. So I want to just make the point that you have these models, you have linear models, you have nonlinear relationships that you can quantify. Okay, and there are enough programs that will do the work for you. You've got multiple variables that you can join up, linear, nonlinear, doesn't matter. There are ways and means of putting them together. And you can then make a lot of deductions, or you can use those relationships to make recommendations to predict disease and look at the behavior of varieties and whatever else you want to do. So regression and correlation is probably, so will tell you that I'm a regression freak. I like to do everything by regression because of the information that it gives you. Sometimes I'm forced to use ANOVAs when I want to compare varieties. But yeah, so it's a very powerful tool to have in your statistical armory when you are trying to make deductions about the behavior of populations. Remember, we started with a population. This is going to give you a lot of information about the behavior of those populations. Okay. Just some closing comments. Now, tomorrow I'll just quickly work through some actual examples with you. You can see how we use the programs, how we make the deductions. But one of my heroes is a chap by the name of Lord Kelvin. He was at Queen's University in Belfast in the 1800s. He was a physicist. And he's known for his numerous, what do you want to call it, useless comments. Okay, but some of them are not so useless. And he makes the point that to measure is to know. If you cannot measure it, you cannot improve it. Okay, and statistics is the tool that we use essentially to measure. Okay, and I love this one, and I give it to my students every year. I often say that when you can measure what you're speaking about and express it in numbers, you know something about it. But when you cannot measure it, when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. It may be the beginning of knowledge, but you have scarcely in your thoughts advanced to the state of science, whatever that may be, whatever the matter may be, sorry. Okay, so statistics is the way in which we interpret numbers and the way in which we develop a science out of that collection of numbers. Okay, so that is essentially what statistics is about. It's been just an introduction, hopefully an appetite whetter. Okay? But what I want you to understand is that if you do not apply statistics correctly, you're wasting your time in the field because you won't be able to interpret it, you won't be able to substantiate your statements, you won't be able to make decent recommendations of your varieties. Okay, so it's the key to making sense of what you're doing in the field. I'll stop on that note. And there's some things on the relevance of Lord Kelvin's statements. Analyses are only as good as your measurements. No amount of statistics can correct a poor hypothesis, poor planning, poor data, incorrect measurement, incorrect variables. Okay. And poor statistical procedures and incorrect assumptions when applying these procedures can make a mockery of good data. So we need to take note of that.